So happy to be here, guys. My name is Marco, and I'm a geology professor at the University of Western Australia. Before going any further, I said Marco, not Mario. As you may see, I don't actually wear any plumbing clothes. It's more like Marco of the Marco Polo game that you all seem to play here in Australia, and that nobody else knows out of Australia. I just wanted to say that. The fact that my second name is Luigi, actually, it's beside the point. I'm Marco, Luigi, and so on and so forth. Anyway, the premise of the talk today is to prove Sheldon Cooper wrong in saying that geology is not a real science. And thank you, Molly, I'm just another geologist is in town. Anyway, I'm not only a geologist, I'm a geochemist, which means I am nerdy about anything to do with the periodic table. And I'm actually excited, I get so excited when we talk about metals, such as platinum, nickel, cobalt, that are critical to what? First of all, I'm nerd about metals, but critical to what? Critical to the so-called energy transition. I think Molly already explained about that, but when we want to basically deal with climate change, we want to develop new forms of energy solutions. So we're talking about wind turbines, we're talking about solar panels. We need metals that are critical to manufacturing these things. Obviously, you can pick your own critical metal or critical elements. You could get helium for more, new ways of travel. Criticality, it's about really what you need to do with the metals you find. I obviously am not local. I came here to Australia, to Western Australia 25 years ago because Western Australia is like a ginormous library of exciting books where books are the very rocks that inform us on the nature of our planet. If there was basically one place, there is no place like Perth, basically. All the books that have been published here are stored here. Another nerdy joke for you here. Anyway, I am actually from Italy, probably you didn't realize that. And despite being here 25 years, I still talk like the way I do. And there is actually a really good advantage to doing that because on a daily basis, I'm asked about whether I'm enjoying my holiday here in Perth. And I actually am. So anyway, let's talk a little bit about what I wanted to tell you about, which is a little bit about what I do. I study a very interesting type of magma known as komatiite. Okay, there are some people here that don't know what the komatiite is, but this is a type of magma that contain the critical metals, not the helium, but the metals that I was telling you about. Just to be sure, I said magma, not maga. This is an important, definition to do that. I said, and I say it in an Italian accent, liquid hot magma. And when I actually go and do about my job, what do? I actually, you know the game Where is Wally? Okay, geologists are a little bit like Where's Wally? They play Where's Wally all the time. And they actually were looking for these little elusive komatiites that like to hide, and they don't want to be found. Actually, in this one, I know that you already spotted there. It's actually there, and if you pay attention, there is always a komatiite associated with it. So in every game, just make sure it's always there. Anyway, as geologists, we get so excited about really, when we find the komatiites, we just spend ages on the outcrop and talking about this and where are they from, why are they here, what are the critical metals, and we get so nerdy about it. The problem is that we get so entrenched into it that we forget about everything else. And that's probably why my office looks something like that, okay? And my colleagues know about that. The problem is that it's really actually terrible, and my family is concerned to the extent that my 18-year-old daughter just enrolled in a psychology degree. I was hoping she would be a geologist, but she didn't. Anyway, what do we want to do? what do I really do? I haven't told you yet. Basically, I spend most of my time traveling around the most beautiful places on Earth, some not so beautiful places on Earth. Every now and then I used to, and sometimes I still deal with chemicals, and I try to basically analyze the rocks, the comatids that I collect from around the world into the lab. What to do? Basically, I want to perform surgery on these rocks. I want to really understand what these rocks can tell me about themselves. And I end up generating plots that look like this. There are, lots of data points, and what do I do with them? I try to use this kind of geochemical information, just to inform on which are the comatids that contain the critical metals I was telling you about, and which are the ones that don't. And it turns out that the best element to do, it's known as ruthenium. I bet nobody knows what ruthenium is, but I do know that, and it happens to be my favorite metal. Why is that? Because my wife, my beautiful wife, is called Ruth. And when I actually presented my wedding ring made of ruthenium to her, she said that I just wanted to marry my job. And she probably is right. The thing is that when I told that very story, and I was so proud of it, to my very friends, they laughed at me because they said that I had selected the cheapest of the precious metals. Anyway, this is Comatia is actually to provide us with a treasure trove of information about how and when our planet was at its baby stage, about 4.5 billion years ago, all the way to the planet, the beautiful planet we have today, that is a middle-aged planet, like me, the middle-aged part, not the planet part. And comadians are fantastic. They give us, again, I'm so entrenched about that. They give us information about so many different things. Would you believe that if comadians had not happened, we actually wouldn't have the continents and the emerged land we live on? And potentially, humankind would have developed as fish, okay? Comatiids are there, and they help us, and they help the planet to develop the atmosphere that we breathe, and the blue skies that we admire every single day, unless you are in Ireland, obviously. And I had made that little joke also for my Irish wife, who is not here, but I could put it in. Anyway, I could actually I'm so excited that I couldn't keep that to myself all the time. I needed to do and put together a center. And I'm the director of this center here. It's a very long name. I won't give you the acronym for it. But basically, the center is basically a way to invite everybody to play together and find out how we can find more critical metals for the future. And what makes this center stand basically out of all the centers that are around the world is that it's a center that welcomes everybody. What do I mean with that? It's not only for geo-nerds like me, it actually is for mathematicians, environmentalists, physicists, you name it. Why is that? Because we are dealing with a problem that is so much bigger than us, and we need the minds, the best minds in their field to come together and crack it. It's like actually playing. I love it because my job is actually basically being the director of a ginormous playground where people come together and discuss and find ways to really solve and address these problems. So what is it? It's a center that really looks at finding the methods for the future and actually resource our future and really actually do so in the most sustainable way possible. So what should you get out of this talk? The fact that I've been focusing my career on liquid hot magma. Yes, and I said that in an Italian accent just to give more emphasis to it. I actually not support the other side of things. Lots of geologists end up talking about the magas, but I talk about magmas, as I said. But most importantly, what was the premise of the job today? It was proving Sheldon Cooper wrong, and I think I did it, so I'll put a stamp of wrong on it. And I thank you for your attention.